Hello, today we're going to integrate a parametric equation where x equals 2 cosine of t and y equals sine of 2t. So when we graph this equation, this is what it looks like.
So this is the graph of our parametric equation, where x equals 2 cosine of t and y equals sine of 2t, and our domain is where t is greater or equal to -4 or less or equal to 4. And we can write the equation in terms of coordinates. So as you can see, it looks like a bow tie when plotted. And what we need to do is find the area above the x-axis under the curve between x equals 0 and x equals 2.
So the area bounded between x equals 0 and x equals 2 is what we want to find by integration. So our normal integration techniques for an ordinary function of f of x, for instance, we know that the area is given by this very simple formula you do in calculus 1. Now, as you can see, this only deals with the y component. This is a parametric equation. So somehow we need to try and include x. We can very easily do this, as you'll see. We can include our limits of integration, where x goes from 0 to 2 of f of x, but then we take the derivative of x with respect to t multiplied by dt. And you may be able to see that the dt's cancel to give us our ordinary equation. So very cleverly we can integrate parametric equations using this, okay? But the limits of integration are in terms of x. We need them in terms of t. So when x is 0, so 0 equals 2 cosine of t, t is equal to pi over 2. Yeah? And then when x is 2, these are our limits of integration, what's t equal to? So 2 equals 2 cosine of t, we get 1 equals cosine of t, therefore t must equal 0, because the cosine of 0 is 1. So now we can write our limits of integration in terms of t. So we get the integral from pi upon 2 to 0 of f of x dx by dt. Okay, good. So first of all, let's find the derivative of x with respect to t. X is 2 cosine of t. So dx by dt is what? So differentiate cosine of t, that gives us negative sine of t. 2 is a constant, so therefore we get negative 2 sine of t. Okay, that's the first bit of our integral, or integrand, should we say. Okay, and of course we have f of x, which is of course sine of 2t anyway, so we don't have to do anything with that. So our completed form is that the area is equal to the integral of pi upon 2 to 0 of sine of 2t, which is f of x or y, multiplied by the derivative with respect to t of x dt. Right, so all we need to do now is integrate. So first things first, we can get rid of the constants and simplify. This is equal to negative 4, and then we integrate from pi upon 2 to 0 of sine squared of t, and then we have our cosine of t. Okay? Now I got to this sine squared of t cosine of t. How do I get to that? Well, we know sine 2 of t by our trigonometric identity. Sine of 2t is what? It's equal to 2 sine of t multiplied by the cosine of t. Okay, so all we have is we have the sine squared of t, and we take out the or negative 2 and or 2 to give us negative 4, and so we get sine squared of t cosine of t. So we've simplified our integral using the trigonometric identity of sine of 2t is equal to 2 sine t cosine t. Okay, and this is what the area is equal to. Now, what's this integral equal to? Now, I'll show you first. It is negative 4/3 of sine cubed of t for pi upon 2 to 0. Okay, and at the end of the video, I'll prove to you why the integral of sine squared t cosine t is sine cubed of t. But for now, you have to trust me. And if we evaluate this, we get minus 4/3, okay, and 0 minus 1, okay, and that's equal to, of course, 4/3 units squared. We don't know what units are in. But that is the area bounded by the curve between x equals 0 and 2 above the x-axis for our parametric equation of x equals 2 cosine of t and y equals sine of 2t. So, let's finish things off. How do we prove that the sine squared of t cosine of t, when we integrate it, gives us sine cubed of t? So let's first look at the derivative of sine cubed of t. So d by dt of sine cubed of t, okay, since that's the integral, okay, what's that equal to? Well, simply by using the chain rule, we know that we're going to get 3 sine squared of t, differentiate sine, and we get cosine of t. Now look at that. Can you see a relationship? The integrand is that, and the integral we get is sine cubed of t. But there's a difference. We have an extra 3 added on. So all we need to do is simply put 1/3 sine cubed t. Okay? If we put 1/3 sine cubed t, so differentiate 1/3 sine cubed t, we get sine squared of t cosine of t. Okay, and therefore the integral is 1/3 sine cubed of t, but we bring the third out, so it gives us negative 4/3. Okay, pause that if that doesn't quite make sense. But there you have it. We have integrated a parametric equation. Hope that helped.